Hello everyone. Today I am going to explain a project that combines healthcare with wireless technology in a very smart way. It's called Wireless Communication for Remote Patient Monitoring. In simple terms, this project is about how doctors can monitor a patient's health, like their body temperature, without being physically near them. This is made possible by using wireless communication, which sends data from the patient's side to the doctor's side. Think of it like sending messages or updates automatically from one device to another without needing any wires or human interference. It's especially helpful in hospitals where doctors need to look after many patients or in situations like infectious disease outbreak when maintaining distance is important. This kind of system makes patient care more efficient and safe. Patient health check using wireless health monitor. Now let's talk about the actual project. Patient health check using wireless health monitor. This project is about creating a small intelligent system that can measure the patient body temperature using electronic sensor and that sends information wirelessly to a screen monitored by doctor or nurse. The idea is to make the patient monitoring continuous and automatic. Instead of a nurse going to the patient again and again to measure temperature, this system does it on its own and sends real-time update. The best part is that it's wireless, so there is no hassle of cable or connection and it allows monitoring even from different rooms or buildings. Now the project overview. Here is a detailed overview of how the system works. We start by using a digital temperature sensor, which is a small electronic component that accurately measures body temperature. This sensor is controlled to a microcontroller which is like the brain of the system. The microcontroller reads the temperature value and converts it into a digital signal. Then this signal is sent out using a radio frequency transmitter module. On the other side there is an RF receiver module that picks up this signal. Another microcontroller at the receiver end processes the data and displays it on an LCD screen. The whole communication is wireless and happens quickly, making the process more smooth and reliable. This system is ideal for use in hospital wards, homes, or even mobile and medical units. Now the problem statement. The main issue we are addressing in this project is the lack of efficient and real-time monitoring system for patients, especially in busy hospital or during medical emergency. Normally, medical staff need to go to each patient repeatedly to check their vital signs, which can be time-consuming, tiring, and risky, particularly when dealing with contagious diseases. One project solves this problem by automating the processes of checking and reporting a patient body temperature. By using wireless communication, we reduce the need for physical contact and manual data entry. This helps save time, improve accuracy, and ensures that healthcare professionals can monitor more patients efficiently and safely. Now its working principle. Now let's understand how this system actually works. The first step is temperature measurement using a digital sensor placed near or on the patient. The sensor gives out the temperature reading in a form that a microcontroller can understand. The microcontroller takes the value and encodes it, turning it into a format that can be transmitted wirelessly. It then sends it to the data to an RF transmitter which broadcasts it as a radio signal. On receiving an end, an RF receiver picks up the signal. The receiver microcontroller decodes the information and displays the patient temperature on an LCD screen. The whole process happens quickly and display patient temperature on an LCD screen. The whole process happens quickly without any wire. It allows a doctor to get updated temperature reading instantly from a distance, improving patient care. Now the block diagram. The slide shows the block diagram of the transmitter. The process begins with the digital temperature sensor which reads the patient temperature and sends it to the microcontroller. The microcontroller processes the data and prepares it for transmission. It then sends the processes data to an RF transmitter module. The transmitter is responsible for sending this data as a radio signal through the air. All these components are placed together near the patient and they work in coordination to keep the temperature flowing continuously and wirelessly. Now the block diagram of the receiver. This diagram represents the receiver side of the system. The RF receiver module is designed to detect and capture temperature signal sent from the transmitter. Once it receives the signal, it forwards the data to the microcontroller connected to it. The microcontroller then decodes the signal, turning it back and readable temperature data. Finally, the information is shown on an LCD display so that the medical staff can view it easily. The receiver system can be placed on a doctor's desk or in a control room from the patient and still receives accurately and timely temperature updates. Now, hardware and software specification. Our process involves both hardware and software elements. On the hardware side, we have the temperature sensor, microcontroller, RF transmitter, receiver module, and the LCD screen. Each component has a specific role from sensing and sending data to receiving and displaying it. On the software side, we write a program that runs on the microcontroller. The code is what the microcontroller, how to collect the data, how to encode it or decode it, and how to manage communication between devices. Both hardware and software need to work together and perfectly for the system to function efficiently. RF communication overview. RF or radio frequency communicates in the method we are using to send data wirelessly. RF signals are electromagnetic waves that travel at the speed of light, which means they can transmit data very quickly. This type of communication is widely used in radio, TV remotes, wireless headphones, and now in our health monitoring system. RF communication is great because it doesn't require any physical connection like wire or cable. It is perfect for situations where you need real-time data to be shared across a distance, which is exactly what our project needs. Frequency detail. In RF communication, frequency play a very important role. Frequency is measured in hertz and it's determined how fast the signal waves are vibrating. Higher frequency or shorter wavelength means they don't travel far or through walls easily. Lower frequency or longer wavelength which helps the signal travel longer distance and pass through the obstacle. In our system, we have selected the frequency that balances good range with reliable signal quality. So the doctor receives the patient temperature data without any delay or interference. RF module components. An RF communication setup includes two essential modules, a transmitter and a receiver. The transmitter is the part that sends out the data signal and a receiver is the part that receives and processes it. In our system, both these modules are lightweight, low cost and compact, making them perfect for portable health monitoring system. Without these two components, wireless communication would not be possible in our project. RF transmitter description. The RF transmitter we used in this project operates between 2 to 12 volts and can send data across a distance up to 500 feet in an open space. It uses a technique called amplitude shift keying (ASK) for modulation, which helps in efficiently sending data over radio waves. The transmitter is very energy efficient and can easily connect it to the microcontroller. It is a popularly choice in many wireless projects because of its low cost, reliability and small size. It operates at common frequency like 434 MHz or 315 MHz, which are suitable for short range application like this one. The RF receiver, which is paired with the transmitter, works on a voltage of 4.5 to 5.5 volts. It also has a range up to 500 feet and is very sensitive to incoming signal, which means it can accurately pick up even weak signal. It uses very little power, making it suitable for continuous operation. The receiver is connected to the microcontroller, which handles decoding signal and updating the display with temperature data. Like the transmitter, it's compact and cost effective, which helps keep the overall project affordable and efficient. Prototype. This slide shows the prototype of our complete system. It includes all the components like the sensor, the microcontroller, the transmitter, the receiver and LED assembled working together. This system has been tested and it is successfully measured and sends temperature data from the patient side to the display side wirelessly. This prototype demonstrated that our idea is not just a theory but a working model that can be implemented in real life medical setup. It is a small setup towards making patient care smarter and more automated. Now, to wrap things up, our project is simple yet powerful system that uses RF communication to monitor the patient body temperature remotely. It helps reduces manual work for nurses and doctors, ensure continuous monitoring and enable faster response in emergency. By using wireless technology, the system avoids necessary cables and allow healthcare providers to stay at a safe distance when needed. This project can be expanded in the future to include other vital signs like heart rate, oxygen level and even ECG data, making it a valuable tool in the world of healthcare. I hope you like my presentation.